Hello, everyone. We're going to be going over the Chapter 8 and 9 review for Exam 3 today. So, as always, in addition to the problems that we will be going over in this review, it's also helpful to review these items as well on your own that we will go over here in just a moment. So, starting with section 8.1, things you want to go over is going to be using complementary angles to find exact values of trigonometric expressions, and finding values of trig functions of acute angles using right triangles. So those are going to be the main 2 points that you're going to want to review. Then for section 8.2, we have solving SAA triangles, solving ASA triangles, and then solving SSA triangles for their different cases. So remember, there were 4 different cases in that section there for the side angle triangles. So really knowing them for all of the different cases that they have. And then also using the law of sines. That's where we introduced our law of sines, which then led us to the law of cosines. So section 8.3, this is going to be solving SAS triangles, solving SSS triangles, and then using the law of cosines. Section 8.4, we want to find areas of SAS triangles, and we want to find the area of triangles with 2 angles and a side. So section 8.4 is really just solving for an area. Then on to chapter 9 for section 9.1, we want to find polar coordinates of a given point. We want to plot points using polar coordinates, and then we want to convert between polar coordinates and rectangular coordinates. Then section 9.2, really just identifying and graphing polar equations using different methods. So using symmetry, just graphing straight by points, things like that. And then we have our testing for symmetry. Section 9.3, we want to plot complex numbers in the complex plane. We want to use De Moivre's theorem, finding complex roots, and then converting complex equations to rectangular or polar or exponential form. Forgot the word form there. There we go, form. Then all right, section 9.4, we want to focus on adding, subtracting, multiplying, and dividing vectors, graphing vectors, and also finding a vector from its given magnitude and direction. So, all right, so those are all the items that you're going to really want to make sure that you touch on when studying for exam 3. So, all right, let's go ahead and get started with our questions. So first question from section 8.1, we want to find the value of sine of theta, cosine of theta, and tangent of theta from the given triangle. So the triangle that we're giving here is going to be a right triangle. It has one side length of 4 and another side length of the square root of 13. And then we see we have our theta measurement there, our angle measurement that we want to find sine of theta, cosine theta, and tangent theta of. So the first thing that we really want to do is that we want to find the length of our hypotenuse. So let's say we want to find the length of the hypotenuse first. Remember your hypotenuse, which if we labeled it C, this would end up being C squared is equal to 13 squared plus 4 squared, which then that would end up being equal to 13 plus 16. So we get C squared is going to be equal to 29, which tells us that C is equal to the square root of 29. So our hypotenuse length is going to be the square root of 29. Since we now have our hypotenuse, we also have our opposite, and we also have our adjacent, we can go ahead and use our trigonometric functions that correspond to the different side lengths of a triangle. So using the Sohcahtoa method, we get that we have sine of theta is going to be equal to the opposite over the hypotenuse. cosine of theta is going to be equal to the adjacent over hypotenuse, and tangent of theta is equal to the opposite over adjacent. So now looking back here at theta, we know that this is opposite. This value here is our adjacent. And this value here is our hypotenuse. It's always our hypotenuse, the longest length. So now we can just assign each one of these values. So sine of theta is equal to opposite over adjacent. Sorry, opposite over hypotenuse. Oops, that's changing. For our opposite over hypotenuse is sine of theta. This means that we'll take our opposite value, which is the square root of 13, and divide by the value of our hypotenuse, which is going to be the square root of 29. So now we do have this technically in the correct form, but remember we don't like having our square roots in our denominator. So in order to get rid of the square root of 29 in our denominator is to multiply this term by the square root of 29 divided by the square root of 29. This will now cancel out the square root in our denominator, which then gives us now a denominator of just 29. And since we have the multiplication of two numbers that are under the square root, we can combine this to end up being 13 times 29, all under the square root, which is now over the value of 29, which now if we go ahead and use a calculator to find this value, we get that 13 times 29 is going to be 377, which is divided by 29. So we found the value of sine of theta. And for cosine of theta, we have our adjacent over hypotenuse, so this is going to end up giving us 4 over the square root of 29. And once again, we don't like the square roots being in the denominator, so we'll multiply by the square root of 29 over the square root of 29. Now when we solve for this, we're just going to get 4 times the square root of 29 divided by 29. Then lastly, we have tangent of theta, which is opposite over adjacent. So in this case, it will be, oops, wrong color, the square root of 13 divided by 4. And we just leave it at that since it's in its most simplest form, since we don't have any square roots in our denominators. So we were able to find the values of sine of theta, cosine of theta, and tangent of theta from our given triangle, even when missing a value, since we can go ahead and use Pythagorean's theorem, since this is a right triangle. So remember, you can't use Pythagorean's theorem if it's not a right triangle, but if it is, then you can use it, and it is very helpful. So, all right, on to question 2. So for section 8.2, we want to solve this triangle that we were given. So we were given this triangle. It has a side length of 2, one angle measurement as 110 degrees, and another angle measurement as 30 degrees. And the values we're solving for in this case are going to be capital B and lowercase b and lowercase a. So these are our values that we're going to be looking for. So we need to use the values that we are given in order to solve for them. So since we know that our side lengths correspond to their matching angles, a little messy there, but we can say that this angle 110 degrees is A, and our 30 degrees is going to be C. Then this 2 is our little c. That's a capital C, angle C. So we do have some information. We say we have big C is equal to 30 degrees, A is equal to 110 degrees, and little c is equal to 2. So we have values that we already know. Then the next thing that we can do is we can identify what kind of triangle this is. We have our two angles here, but our side is going to be off to, or our side is off to the side here. So we have two angles and our side length is off to the side. We know that our triangles for our two angles on one side is going to be our SAA or our ASA triangles. With ASA triangles, that would be angle side angle. So your side length would be between two angles, and in this case it's not, which means it is going to be a side angle angle triangle. So we can say this is a side angle angle triangle. So all right, we determined it's a side angle angle triangle. We've identified the values that we were given, and now we can start to solve. So in this case, the easiest thing to solve for right now would be to solve for the angle B. And this is because we know that angle A plus angle B plus angle C is equal to 180 degrees. And we know our angle A is 110 degrees, and our angle C is 30 degrees. So this means that we have 140 degrees plus B is equal to 180 degrees, which gives us that B is equal to 40 degrees. All right, so this is not one of our final answers, but it is one of our answers. We have our angle B measurement that we wanted, and now we want to solve for lengths A and B. So now we can use the facts that sine of angle A divided by side length A is equal to sine of angle B divided by side length B, which is equal to sine of angle C divided by our side length C. And now what we always want to do is we always want to use these comparisons with the exact values that we were given. We can go ahead and start estimating values, but we always want to try and use values that were already given to us since we know that those are most definitely correct. So we can use this equality where we also know that sine of angle C divided by side length C is going to be equal to sine of 30 degrees divided by 2. So we're going to be comparing each one of our sides and angle measurements with sine of C divided by C. So starting with angle in side A, we can say that sine of 30 degrees is equal to sine of 110 degrees divided by our side length A. Then if we rewrite this equation, we can write this so that we're solving for A, and this gives us that A is equal to 2 sine 110 degrees divided by sine of 30 degrees. And now we want to use a calculator to solve for this value. And when we do, we end up getting 3.76. So another value here is our side length A. Now I want to go ahead and do the same thing for B. So once again, we're using the values that we know for sure, which was sine of 30 degrees over 2. And we're setting this now equal to B, where we have sine of 40 degrees divided by lowercase b. Once again, rewriting this for B, we're going to get that B is equal to 2 sine of 40 degrees divided by sine of 30 degrees. Then we go ahead, use our calculator, and we get the value. B is about 2.57. So this way we have solved for each one of the factors that we wanted to. So just restating our final answer, you can say thus angle B is equal to 40 degrees. Side length A is about 3.76. And side length B was about 2.57. And that would be our final answer. All right, section 8.3, we have that we want to solve the triangle for B is equal to 4, C is equal to 9, and capital A is equal to 100 degrees. So for section 8.3, we use the law of cosines a lot, and what we've determined is that you don't necessarily need a picture of a triangle. With things like law of cosines, you don't have to have the picture as long as you have values. If drawing out a picture helps, then by all means, draw that picture. But all right, first thing we want to do is we want to identify what kind of triangle this is. In section 8.3, we only had two different types of triangles. We had side angle side, or SAS, and our side triangles, which were SSS triangles. So in this case, we have two sides at an angle, which means that this is going to have to be an SAS triangle. Since we have two sides and one angle measurement. So we've determined what kind of triangle it is. Now we want to go ahead and use the law of cosines. So using the law of cosines, we know that, and this was stated in our notes and in our book, we get the formula a squared is equal to b squared plus c squared minus 2 times bc times cosine of a holds. We can rewrite this equation, remember, for each one of our side lengths. So we also get that b squared is equal to a squared plus c squared minus 2 times a times c times cosine of b. And then c squared is equal to a squared plus b squared minus 2 times a times b times cosine of c. So we have those as well, but this is going to be our first relevant equation. So plugging these values in, we do not have a value of a, so this will just be a squared is equal to b squared, so 4 squared, plus c squared, which is 9 squared, minus 2 times 4 times 9 times cosine of 100 degrees. Rewriting this once again, we can now write this as a is equal to the square root of 16 plus 81 minus 72 cosine of 100 degrees. Which, if we go ahead, plug that in a calculator, we end up getting that this value is 11.03. So we found the value of A, our side length A. So now we want to find the angle B. So to find B, we can use the law of cosines again. If we have this way, we know that b squared is equal to a squared plus c squared minus 2 times a times c times cosine of b. So plugging these values in, b is going to be 4, so we get 4 squared is equal to a, which we stated was 11.03 squared, plus c squared, which was 9 squared, minus 2 times 11.03 times 9 times cosine of b. So remember, b is what we're going to be solving for. So if we want to write this in just terms of cosine of b, we would end up getting that cosine of b is equal to 16 minus 11.03 squared is going to end up being 121.66 plus our 81, or sorry, minus an 81 since we subtracted it then when we rewrote it. This is all now divided by 2 times 11.03 times 9, which comes out to a negative 198.54. So this was rewritten and calculated now so that when we do want to solve for just b, now I have that b is equal to cosine inverse of whatever this value is going to be. So if we simplify, we end up getting 186.66 divided by 198.54. These values are positive and not negative because we see that our denominator before was negative. When we simplified our numerator, it was also negative. So essentially our negatives canceled out to give us this positive value. Now, if we go ahead and plug that into a calculator, we get that our angle B is going to be about 19.9 degrees. Then if you really wanted to use this exact same method to go ahead and find for the angle C, you could definitely do that. The other choice that you have is that you can add the values of your angles A and B together, subtract that value from 180, and that gives you your value or your angle measurement of the angle C, which is the easier way, so we're going to go ahead and do that. So lastly, that A plus B plus C is equal to 180 degrees. So we have 100 degrees plus 19.9 degrees plus angle C is equal to 180 degrees, where then this simplifies down to 119.9 degrees plus C is equal to 180 degrees, which finally gives us that C is going to be equal to 60.1 degrees. So we found all the values that we were looking for. Now we just want to wrap this up in our final answer. So we could say thus A is equal to about 11.03. Angle B is equal to about 19.9 degrees. And thus C is also about 60.1 degrees. So this would be our final answer here.